Carson and Andrew, I will give you each a dollar bill if you reference this next class that you see me. Cool. All right, so here we are. We are dealing with the triangle inequality. Now, I don't have the theorem showing on my board. You probably have it in your notes if you were to look. Can you tell me what the triangle inequality says without, you don't have to give me all the different parts of it, but just the essence of it. Can you tell me the main thoughts behind the triangle inequality? If I add up any two sides of the triangle, so yes, you switch direction, but you're cool. You are correct. Two sides, any two sides, they add up to a value greater than the third side. Has to be that way because we can't make it work the other direction. Now, with that in mind, we did a problem yesterday, which this was right at the end of the hour, I believe. So I didn't really get a chance to check. Did you guys understand what went into this part of the problem? Like how I put these points on here and the lines that I drew? The overlap, I'm not concerned. I think it's pretty clear. Raylene, just so you know, if you're watching this, you also get $1 if you reference it. Just those three. Okay. The overlap is pretty, I hope. Do you guys feel okay with identifying the overlap? Can't tell. Okay. Do you feel okay with making these three lines? Okay. So we could do the exact same type of problem, or which is where mathematics starts to get challenging. The hard part of math, and maybe all of it is hard for you, but I think the hard part that most students encounter with math is if I give you this problem and then I give you another problem exactly like this, everybody can do it. Now, there's a weird little distinction here between if I am just looking at this and plugging in the exact same stuff, could you do the problem without really understanding it, do you think? If it's the exact same type of problem, could you just substitute in different values and do the same thing? Is that really doing math, do you think? I don't know the answer, just so you know, like you also don't, it seems, which is fine. Now it depends, right? Like maybe it is, maybe it isn't. But I'm going to show you what for sure is doing math and what I think makes math challenging. And I'm just curious if you guys agree from a philosophical point of view. So on B, we're going to use the triangle inequality, but it's going to look very different. So for this one, let me get we'll just do it here. Very different feel, but the same concepts. And it's just being able to take the same tools and apply them in a different situation. Like we all know that you can use a hammer to nail in a nail, right? But if I showed you how a hammer works and say, oh yeah, this side puts the nails in and you use this side to take it out. And then I show you guys like, hey, here's how you hammer a nail in. But if I've explained and at least covered that the other side takes the nail out, if I give you the hammer, even though I didn't show you, you could still probably figure out how to pry out the nail, right? Like, here's the tool, the basics of it, now use it in this different situation. The same thing happens in math, and it's what makes math more and more challenging as you get going further and further, because we can't look at every single possible nail, but all the nails get hit in with a hammer. I don't know if that analogy makes as much sense in your head, but I kind of love it. I'm going to refine it for fifth hour. But here we go. I'm going to ask you a simple question. Does the triangle exist? That's it. I'm going to give you, I want you to give me triangle ABC, and I'm not going to write those down, but here's what I'm claiming. Side A of this triangle is 13. Side B of this triangle is 12, and side C of this triangle is 25. Does this triangle exist is the only question, and it feels different, but I assure you the triangle inequality applies in the almost the exact same way as yesterday. Now, the other part that I would typically add is to justify, which means I need you to not necessarily write like a big paragraph and sentence, but show me why you say yes or why you say no. I'm going to give you guys like 60 seconds, and I just want to see what you come up with. We'll meet back up. If you have no idea where to start, chat with your neighbors. There's only 5 of you. Collectively, you can all chat with each other without even moving. Cool. Ray might already have an answer. Yeah. Love it. Any two sides should add up to set greater than the third, right? So as we're looking at it, if it's not immediately clear which one it is, we can just try. Now, unfortunately, the first one that I would probably try and you would probably try is a plus b and compare it to c. I did not mean to just give it away on the first check. So I'm going to start in a weird order. If I took 12 plus 13, is it greater than the third side of... I just said I wasn't going to do this. If I took 12 and added it to 25, is it greater than the third side 13? So I'm just picking any two, and I'm doing it in a weird order than what is natural because I want to see them. This is not true or not false. Weird. Let me rephrase that. Is this true or false? That's true right there. And I know that because 25 is already bigger than 13. It's definitely true. Give me another pair of sides. It's not the one that I need, really. If I did 13 plus 25, I need to know and I need to verify that that's greater than 12. For the same logic, yes, of course it is, because 25 and 13 are both bigger than 12. If we add them up, it's still bigger than 12. Now, in the end, I do want to stress just one last time, you would not have done this order. I don't think. Is everybody's first thought 13 plus 12? And that was unintentional. I didn't mean to give it to be obvious. But if we ask this question, 13 plus 12, is that greater than 25? Is it? No. What is it? It's equal, not greater than. If any of these three fail, the triangle fails. So we'll just say, therefore, no. Triangle ABC, and you don't have to be this formal, just a no is fine, just so you're aware, does not exist. Now, I'm going to introduce this now in hopes that I get you guys in a couple of years. I'll have you next year, obviously. But in a couple of years, DNE, what do you think it stands for? Does not exist. Cool. Very different problem, but can you tell that we're using the exact same theory? Okay, let's do one more. I want you guys to do last one. I'm going to give you about 60 seconds for it. Here we go. On C, I want you to find me the range of possible values of x. Now, we're going to be given a triangle. I'm going to write it down a little bit differently. I'm going to write it as I lied. I'll just write it the same as I have been. Let's say that R, some side of a triangle, is equal to, 67. S is equal to 41. And I want to know what is x. Find me the values between which x must exist. So the lower bound, the smallest possible value, and the upper bound, the highest possible value. And we'll chat in about 60 seconds. Ooh, big moment of truth. Is Facebook available on my computer? You think it is? I don't know. Your numbers on your number line are going to be 108, 26, negative 26. Okay, as we think about it, I saw you guys using the number line. We don't really need it, but it does help. Do you want to try to do it without the number line, or you just want to commit to using the number line? Without? Okay, so check it out. One of these automatically implies the other. And that, I don't know if that's really clear, but I think that if one of them is true, the other one is definitely true. I think that if you give me a number bigger than 26, no matter what you pick, is it going to be bigger than negative 26? I think this one is the one that I don't really care about then. It's already been covered by another. I'm okay with it. So as I'm looking at this, I know that it has to be bigger than 26. So I'm already thinking this is my lower bound. But at the same time, it has to be less than what? 108. So which means x must be stuck between those. And I'll introduce a couple other lines of logic if we need. But I think that 26 is the smallest possible value. X has to be bigger than it, but it has to be less than 108. Now, on the number line, do we get the same answer? The number line can be very helpful if you struggle with thinking about these things, and they can be challenging. What I want to think about here, and we're just going to scroll back up to A here in just a second. I wound up using these, right? And help me out here. 41 is the long, the short, or the unknown? So short, and that was coincidence that it's S. And let's see, 67 and 41 were here. And let's see, so this one is unknown. And then this one would be considered long with what we have, right? And are you guys okay with how I chose those? One of these is the smallest, one of them is the longest, one of them is unknown. If we look at what we used here, we checked, and I'm just going to see, we did short plus long is greater than X. Or if you'd rather, X is less than the short or the smaller number plus the long or the larger number. Do you guys agree that if with this, that's what we used? Okay, on this one, we also had that this one, and I'm going to rearrange it so it's not just X. Is this short or long right here? Short. So the other inequality that we checked is short plus unknown has to be greater than the long. Now, that's what we wound up using for our answer here. And we had to go a step further, but I just want to go back up and see if we did the same thing. So for our less than, we had short plus long. If we look at this one, we said it had to be less than 18. Was 18 short plus long? And we said it had to be greater than 12. And just to check, is that short plus unknown? We can totally skip this third one and get the exact same answer. We only truly have to do these two because one of them is always going to cover the other one every single time. And what I mean by cover the other one is if we look at this, it looks like the green one was a nonsense. This overlap from blue is already covering everything else in green. So the green doesn't change anything here. Cool. All right. Last little piece, and we're taking our final one here on Wednesday, right? Okay, perfect. Okay, last little pieces here. If I know the sides of an angle, or a triangle rather, do they somehow relate to the lengths of the sides, do you think? Holy cow, I just said, do the sides relate to the sides? Of course they do. Do the angles relate to the sides? So help me make a triangle, like, do you guys know any right triangles off the top of your head, any of the lengths of them? So those are angles. How about any of the lengths? But I mean, I agree, 30, 60, 90 would satisfy that. Okay, we're just gonna make a claim real quick. 3, 4, 5 is a right triangle. Now, if we look at this, and this, I don't know why your book does it the opposite way. We're just continuing on, and we're just gonna talk for a couple minutes. I'm not gonna give you more homework this weekend, and then we might be in a mad dash on Monday. It won't really be a mad dash, but on Monday we'll have to finish the last section. At least look at it. So check this out. I want to apply the triangle inequality, or at least ideas behind it, triangle inequality, to angles. And it's a weird idea because it's not really the triangle inequality because it only mentions the sides, but there is a relationship between the length of a side of a triangle and the angles of that triangle. There must be. Now, if we look at this, there are 3 situations that we're after. And I just want to look at them here. We're going to use this to work it out. Let's consider a right triangle first. Now, over here, I might do an acute triangle. And over here, I might do an obtuse triangle. And by might, I mean I'm going to do these. I don't know why I said the word might. Okay. Ray, I appreciate it. You gave me a right triangle. And I'm not going to draw it to scale other than the fact that it's going to be a right triangle. And it doesn't look like it. It's not to scale. Ray thankfully told us that 3, 4, 5 for our side lengths make a right triangle. And I am going to draw this a little bit more to scale, just it's going to be easier to see. I don't know that that really changed much. We'll make it more obnoxious. There we go. Okay, here's my lovely right triangle. And we had 3, 4, 5. Now, how would we verify Ray's thought that this is a right triangle? How could we confirm his idea? Yeah, the Pythagorean theorem. And 3 squared is 9 plus 16 is 5 squared. So it works out pretty well there. Now, as we deal with this, here is the easy question that is going to seem odd for just a second. But let's name this triangle. We'll just go A, B, and I will call the right angle C so that it looks normal with A squared plus B squared equals C squared. Okay, as we look at this, It's going to sound like a silly question, but can you guys tell me the largest angle on this triangle? Is that cool with everybody? This is the largest angle. Like it has to be. The other two can't be 90 because then we'd break our 180 rule. So we'll just put a little note here. Largest angle. Now, in previous books, I've seen this called the Pythagorean inequalities instead. They don't even name it in this book. I like calling it the triangle inequality because the same idea works out. Now, by coincidence, maybe, what's the longest side? Where is it across the triangle from? This is the longest side. Okay, we are going to pick up here on Monday, but I do have one little challenge for you. I want you to do the same thing and think about these ideas, and we'll pick it up here. But assume that we have a equilateral triangle. We won't do those numbers because it looks scary. 5, 5, 5. And then let's pick a really obnoxious, obtuse angle. So maybe that's 4 and 10 and 15. I want you to think about what is the smallest or biggest angle and where is it in relationship to the smallest or biggest side. Cool. No formal assignment. I'll see you cool cats and kittens on Monday. Chess meeting at lunch if you're interested in learning or playing. Come check it out.